Okay, here we go. We want to find the area bounded underneath x cubed from 0 to 3. What is the width of the entire interval? 3 is the width of the entire interval, so therefore the width of each rectangle is 3 over n. So remember that delta x ends up being, or your width ends up being, b minus a divided by n. And yesterday what we also learned is that your x sub I value is simply a plus b minus a over n times I. So for what x values do we evaluate the sum? What are our x sub I values? Well, what is a in this problem? 0 plus b minus a over n is 3 over n, and we multiply that by I. So let's understand what we're doing from a calculus perspective. The integral from 0 to what? Of x cubed dx. That's equal to the limit as n goes to infinity of sum from I equals 1 to n of what do I plug into the function? Yeah, 3I over n, that thing cubed, times 3 over n, which is delta x. So again, let's just remember that what we've been doing is we've been taking the width times the sum of the heights, right? This is the width. This is the sum of the heights. That's what we're doing. So, no big deal. Limit as n goes to infinity of the sum from I equals 1 to n of, what is 3I cubed? 27I cubed times 3. Very good, 81I cubed. What's in the denominator? N to the 4th. You want to rewrite this so that you only have an expression with I. So limit as n goes to infinity of 81 over n to the 4th times the sum from I equals 1 to n of what's left over? I to the 3rd. Oh man, I wish that there was something I could put in place of this thing right there. N squared times n plus 1 squared over 4. Yeah, easy. This stuff's easy. she'll pick it up, no problem. Limit as n goes to infinity then of 81 over n to the 4th. And you guys told me put in that place n squared times n plus 1 squared all over 4. Yeah. And you can sometimes take some shortcuts. Like, would you like to cross off the n squareds? So I would have the limit as n goes to infinity of, if I multiply, what's n plus 1 times n plus 1? Yeah, if I distribute that 81, I get 81 n squared plus 162 n plus 81 all over what? 4n squared. Yeah, take out the n squared limit. N goes to infinity of n squared times 81 plus 2 over n plus all over those cancel. Those go to 0. Why do they go to 0? Very good. As n goes to infinity, n becomes significantly large, and so something over a very large number becomes 0. So you get 81 over 4. That's the exact area. Yeah, like yesterday, it took us how long? Yeah. Whoa! 5 minutes, 47 seconds. Not bad. Oh, we're going to do one more, and then you can have the rest of the hour to work. Yeah. Uh-oh. What's different about this one? I've got two terms, right? Two terms. So here's what we're going to look at. Today, we're going to look at a problem that has more than one term. What do you do when it has more than one term? We're still starting at 0. Tomorrow, what we're going to look at is this, is what if we have more than one term and we don't start at 0? So tomorrow we'll do one problem, and then you have time to work. Today we just do one more problem, and you're going to have time to work. So I am trying to make sure that we honor your time in the process. So, you're welcome. Shania, yeah. So, we just did the infinite limit of Riemann sums, so it's not a big deal. Like, child's play right here. Okay. All right, the width of the interval, 4. So what's going to be width of each rectangle? 4 over n. For what x values do we evaluate the sum? 4I over n. Now, I want to be clear. A lot of times people just take this width, they're just like, oh, you just put an I up there. You're right if we start at 0. But if we don't start at 0, suppose we change this, it was 1, it'll be 1 plus that, right? So we got to shift everything over. So that's what we're doing. I've actually, I don't suggest I'm necessarily good at teaching this right now, but I'll tell you what, I'm at least better than I was 8 years ago. It used to be really bad. Like, I don't think anybody understood what was going on. We were just plugging stuff in. So hopefully you get a little bit of an idea of what we're doing. Hi. Another no packet for Shania. All right. What do I write? Integral. 0 to 4. 2x minus 1 half x squared dx equals limit n goes infinity sum equals 1 n of 2 times 4I over n minus 1 half times 4I over n squared. And I have to multiply all of that by 4 over n. That's a little bit more. Let's be honest, folks. Like, the calculus is basically done. The only thing that involves calculus is we'll do the limit as n goes infinity. But otherwise, right now we're going to be doing algebra, right? Okay. So the thing that you love, algebra, that's what we're going to be doing. So enjoy it. Limit as n goes to infinity of, what do you want to do first to simplify this? So from I equals 1 to n of what? What do you want to have? How do you want to write this? Okay, Bailey's taking the lead. We got 8I over n minus 8I squared over n squared times 4 over n. How did I get 8I squared over n squared? I took the 4I over n squared, and I get 16I squared over n squared times 1/2 is 8I squared over n squared. Okay? Still need to distribute that 4 over n, don't I? So we get the limit as n goes to infinity of the sum from I equals 1 to n of 32I over n squared minus okay. Yeah, here's where, so you have some options here and how you want to deal with it. I'm going to break it into two sums. So remember, this is just the sum of something, correct? So, and notice that there's addition and subtraction separating these. So it's no big deal to break sums into sums. Agreed? So like if you're going to add up the numbers 1 through 10, you could either add them all up or you could add the odds and then the evens and add them together, right? It's no big deal. That's what we're doing. So we have the limit as n goes to infinity of, I'm going to have, if I factor out the 32 over n squared, I have 32 over n squared times the sum from I equals 1 to n of what's left over? I. Plus, and then, oh, I'm sorry, not plus, but minus, what do we factor out of the next set? 32 over n cubed. Sum I equals 1 to n of what? I squared. Great. Okay. So limit as n goes to infinity, if only I had something I could plug in for the green and for the red. Thirty-two over n squared times n times n plus 1 over 2 minus, well played, times I, most people don't like that one. I don't like that one. It's my least favorite one. But that's a total lie. Teachers definitely have favorites. So limit as n goes to infinity. So let's work out some algebra here. What could I cancel off? What do you want to simplify? So the n can go away, and then the 32 over 2 could be 16. So I'm going to have n in the denominator, 16 in the top. So would you agree I have 16n plus 16 over n? Minus, the n is going to make that an n squared, and then 32 over 6 I can make 16 over 3. Okay, let's multiply this top. 2n times n. So I got 32n squared. And then what's going to be in the middle? 3n? Yeah, so 3n. And 3 times 16 is 48n. So I got plus 48n. And then, yeah, I got a plus 16er. All over 3n squared, good. And I want to pause so you can do a check to make sure you're on the right track. Did you notice that you have an I here, but you have an n squared down there? You have an I squared there, but you have an n cubed down there. The i's are always 1 degree less than the n's. And then when you substitute something for the I, notice how you come up with n times n, you come up with that n squared. So when you get to your final limit, you should definitely have the same power in the numerator and denominator. Okay? And so let's go. Limit as n goes to infinity. You guys are almost there. What do I factor out of the top? Just factor out the n. That'll be sufficient. You're left with all over n, which we know that those are going to go away. Great. Minus, what do we factor out of top there? N squared, we're left with good. 48 over n plus 16 over n squared. I heard you guys say it. Excellent. All over 3n squared. And you know the 3n squareds cancel, or the n squareds cancel, excuse me. And as I'm letting n go to infinity, the terms that have powers of n in the denominator go to 0. So that's calculus. When we allow things to go, I mean, the calculus is easy, right? Like, there's your calculus. Yeah, it's the algebra that's the pain in the butt. So then we get 16 minus 32 over 3, which is 48 over 3 minus 32 over 3, or 16 thirds, which I happen to know is 5.3 repeating. I'm kind of, particular about making sure I do things right. I don't like making mistakes and getting things wrong. So I'm going to go to my calculator. I'm going to type in 2x minus 0.5x squared. I'm going to zoom standard so I can see that parabola. It looks like I'm finding the area from 0 to 4. Calculate which one? Number 7, that's our integral. It does area. We go from 0 to 4, and it's just cool, folks. Yeah, well, you just have fun. We'll try.